Okay, well, we've had some questions about the mill here. Let me turn it sideways so maybe we can get a little better picture. It's kind of dark outside, and I apologize for that. I just kind of got it in my head to make this video now, which didn't make a whole lot of sense because the middle of the day would have been a lot better. But anyway, here's the table. This actually goes up here, but I leave it off so that I can access the top of the spindle, which actually has all of our belts and everything else on it. You can change your speeds. There's actually another one that the previous owner put on there that allows you to go even faster, I believe. This is your drawbar, which you'll use to tighten and loosen and change out your collets. This actually does come with a collet holder, so you'll be able to rapidly change end mills and whatever else you want to put in there. I'm not sure which holder this is, but you can find them on eBay. They just fit inside of a standard R8 collet holder. And anyways, you can see it's in really good shape. I mean, it's hard to tell. It's kind of dark, but maybe I can get some light here. I'm not real sure. I'm sure there's one on this camera, but I'm not real sure where that is. Anyway, so here's our control box, and we'll go ahead and go through the motions. This actually comes with 4 drivers, so you'll have the option of using a 4th axis. This goes to a rotary table, and you have another axis back there. I don't know if you can see that. And yeah, I'm starting to think doing this at night was a really bad idea. This is your control cable that'll connect your drive rack and all your drivers to your computer. But anyway, we can jog all of our axes with this little device right here. This is a pulse generator, and this actually takes over for your computer when it comes to actually generating the pulses that go to the axes or go to the drivers, I'm sorry, that power the axes. So we're going to turn this on. We'll go up to about, it's on all the way, we'll go to about, I don't know, 60%, I guess. Resolution is on low. We'll kick that up. Speed is on way up. Feed rate over, that's the feed rate override. So this will go whatever you program it. 100% would be full speed, and you can go above that, you can go below that, depending on what your conditions are. If you find that your programmed feed rate was too high or too low, you think you can go a little faster, you can up that a little bit over here, or decrease it depending on, again, what the conditions are. And I'm getting off track, but here we go. We're going to start with low resolution and see how that works. We're going to go with the x-axis. Hang on one second. Okay, we're back. Sorry about that. This gray wire back here was disconnected for whatever reason. That's the plug that connects our pulse generator to the drive rack. So yeah, it's important to keep that plugged in. That was not plugged in. I was a little worried there. But anyway, let's get back to the mill and see how it works. So we're going to draw the x-axis right now. We're at low resolution. I don't know if you can see that. There we go. Low resolution. So we're going to take a look now. And you can see it's pretty moderate as far as speed goes. We can go up on that and go a lot faster and probably bump into our drive rack. We will try the y-axis, I'm sorry. See that going? And it hits our limits. We have limit switches that automatically stop the machine from overriding and going too far and actually damaging anything. So we're going back to the Y, and as you can see, it's going back. We could probably increase that resolution. That just means that you're operating at a higher microstep. Is probably what that means. This one probably maxes out at about 10 microsteps, which is pretty standard for a serious mill. You start to lose torque whenever you go above 10 microsteps. In fact, you lose torque at 10 microsteps, but it's not as bad as if you go up to, 128 or something crazy like that. It'll be a lot smoother, but you won't get as much torque out of your steppers. That's one of the drawbacks of using big healthy steppers like this. But if you work within their boundaries, they're great. And you can see my Tormach over there. It also uses steppers. And again, within their boundaries, they're perfect. They work really, really well. And I can tell you from experience that Tormach will do the job, and so will this mill. So we're going to go with Z. So we're going up and down. It's like it's squeaking. Squeaking just a little bit. Oh, yeah, it's got to tighten that up. It's got a loose bolt in there. I gotta tighten up. I'll go ahead and bring it up, or I guess it's down. And you can see our limit switch working. It's an optical or a capacitive or whatever kind it is that senses when something's too close. So that's up. We're going to go back down. I just kind of hand tighten that bolt. That's why it's not making that noise anymore. One thing you'll notice on this mill that makes it, I think, better than the standard kit is that we have this thing here. There's this magic happening right here. The guy who owned this was a tool maker by trade, and so he put a much more precise screw in there, and God, I wish we could see this better. But this whole blue part that you see right here is added. The kit that it came with actually came with a stepper that mounted here, and that went on to a worm screw, and it was really bad as far as accuracy goes. This setup here is far superior when it comes to accuracy. And he's got a really nice high accuracy lead screw, along with some linear bearings in there. And again, he just did a fantastic job on this. But anyway, let's we don't have an A. We'll go a little faster. Just crank that resolution down, turn the speed up. X. Y. We'll go ahead and go all the way over, so we can take a look at some of the at the ball screws that are, and we can't see those at all. Unfortunately, we can't see those at all. We're gonna have to redo this in the daytime. We're going to come all the way back to this, just because. And just for the hell of it, let's fire up the spindle. See what that sounds like. Okay, that's our spindle right here. So we'll see that turn. And we're going to go forward. And it's smooth as silk. One reason for that is that he put a brand new motor on here. I don't know if you can see that, but it's got a brand new Marathon motor on it. That's not stock. And it's a little dangerous, but we're going to go ahead and look at this. See all that working perfectly. Stop it. And we'll go to reverse, just for the hell of it. Again, it's perfect. This is for just mounting a, in fact, we could take that off if we want to. You probably don't need that for anything. If you need to go up higher, you can actually crank this up a little higher if you want. If you have a piece that's just too big to fit under there. And then once you get it up high, as high as you want it, you just lock it in place with these. In fact, you can go pretty tall with it, but for most projects, you're probably going to stick with what you got. But anyway, I hope this was a pretty decent tour. Again, I should have done this during the daytime. But this is it. And anyway, I hope this answers any of your questions. If there's something I didn't cover, please feel free to ask. And that concludes our video. Thank you. And I just recorded myself saying all that. Can I?
Yeah. Do you not have software on your computer to do it?
Probably not. I've never fucked with the video.